I suppose you are preparing also tools for designers and maybe students and researchers to use this kind of approach. Which could be the difficulties or maybe the main advantages in selecting one of the two approaches that you propose?
Well, let's say that there are two different uses for each approach. For example, in the case of the vector-based one, it's quite intuitive to see the parallelism between edges in the form and the force diagram. This might be particularly useful for applications like these pedestrian bridges, or for example, large span canopies for roof structures. In the case of the polyhedron-based approach, on the other hand, there are other applications, like, for example, what Marina was showing. In this case, this more intricate structure with many different nodes that are difficult to control, for example, in the case of the vector-based, or even further applications. For example, we can also work with a polyhedron-based to derive right away a stress field within a structure. And this is particularly helpful, for example, in case of reinforced concrete structures.
Okay, there's a question from Sigrid Adriansen.
Yeah, I have a question. So these techniques have come to the foreground, I don't know, in the last 10 years, and they're very powerful, and they're really, I don't know, like they're very intuitive. So I think these are like really great techniques for engineers and for architects and for designers. I wonder whether you could provide a little bit of perspective as in where is this going next? What are the new exciting, because of course these are old techniques and you know, this is already new research, but so what is the biggest challenge, or where are these techniques going to be in 5 years time? What are still the fields that need to be tackled that haven't really been tackled yet using techniques? So basically, where are these techniques going next?
Yes, thank you very much for the question. So there is still, on the one hand, quite a lot of work to be done in terms of bringing these techniques that are now still partially theoretical into actual tools that can be used by designers in everyday tasks, for example, for designing, for making form finding of structures. So there is still quite a lot of work to be done in that perspective. And at the same time, what is interesting is to show these techniques mostly they show their power in terms of the early conceptual phase of the design. Once actually there is not already a fixed geometry, or it's really about trying to develop and find a structure. It's interesting to see how these techniques can be actually connected and related to other approaches. So it's not the idea that these tools, 3D graphic statics tools, are replacing all the tools that are available in structural engineering. So it's interesting to see the interfacing between these, for example, and FEM, and see how actually these tools can be combined, for example, graphic statics for the early phase of the design, and then developing further on the design with other approaches and techniques.
Another thing to mention is that, as you say, it's true that the fundamental theory of this can be traced back to 19th century, 18th century, and even before that. However, in the last 10 years, there have been also generalizations of those fundamental theories. For example, the 3D polyhedron approach is something that it was developed recently, even though it is rooted on a theory like 300 years ago. And another thing that Pierluigi already mentioned, I think, is that these techniques and methodologies can be also quite useful when applied to specific cases. So now that we know a bit the theory, it has been generalized a bit, we can start applying it in a cross-disciplinary fashion and see what we can get out of it.
Okay, so we are a bit short in time, so I want to thank you again, Pierluigi and Maria.
Thank you.